Hi, we are Group 10 and our project is on data deduplication. The team members are Sahil, Prachi, Casper, John, and Rishi. Data deduplication tries to exploit similarities between files so as to eliminate storing redundant data and save disk space. In our project, we efficiently store arbitrary files and directories with no prior knowledge of any similarities. In our project, we implement everything that a file browser does. Our framework is essentially an interface that implements functionalities of a file browser, such as adding, deleting, and retrieving files and directories. This slide is an overview of how our project is structured. The CLI, GUI, and web interfaces are agnostic to the deduplication implementation. We have several implementations of the dedupe interface, and the final implementation of a project uses a rolling hash locker and an SQLite database on the backend. The database contains two separate tables. One stores the file metadata, while the other contains file data chunks. Next, I will briefly go over database implementation. The SQLite database is implemented as a B tree. All operations take log of size of the database amount of time. This slide shows the asymptotic time and space complexity of a project. Through our testing, we found that adding a file takes the longest time among all of our operations because it may require going through all the rows in the database. However, adding a file is fast if it matches very close to the data chunks stored in the database or if it is very distinct from them. All file and directory operations have a space complexity based on the size of the database tables. Next, we will demo our final project implementation of Data Deduplicator.
Here is a short demo demonstrating how the rolling hash is implemented in our locker. We have a simple locker initialized already using the database. The definition of the table where the data chunks are stored is given here. Every data chunk will have, if it's a unique file, a data blob, a hash, and a block number which is required to reconstruct the file when the file is to be retrieved. In case if the data chunk is not unique, it's duplicate, then the data block column will be empty, while the reference UUID blob will be populated with the UUID of the data chunk wherever it is stored in the table. Now let's see how the rolling hash works. We have two files here. One is a simple file having the 26 alphabets, and the other one is file with the same 26 alphabet with extra two blank spaces. Now let's start adding the first file. I have set the chunk size for this demonstration to 4 byte so that we can see how this file gets chunked into different chunks and gets stored in the database. Let's look at that. If we look into the table data, we can clearly see, since this is the unique file, that the data is stored, and for every data a unique UUID is created. As you can see, it's a 4 byte chunk size, and all of the data is stored along with a chunk number that is required to build the file again and its unique UUID. Now let's put a slightly similar file and see how the rolling hash, does the rolling hash actually find out the similar chunks or not. And once it's added, check again. Now as you can see that for the first file, this is the file UUID and this is the second file UUID. You can also verify that by using by checking the other table, that there are two files added and each one of them have a specific file ID. And having said that, the first file had a data column filled up, but the second file which was added, since it was duplicate chunks, the first two blank spaces were unique, right? So that was detected and it was stored along with its unique UUID. But for all the rest of them, the reference UUID, which is exactly same as it detected from the previous file, and the chunk numbers are different because they are shifted by 2 white spaces. So as you can see that this chunk really clearly matches the one that is here, and so on and so forth. This is a simple demonstration of how our rolling hash actually works. Let's quickly look at the CLI we developed for our project. The whole software is contained in this .jar file, which makes the installation portable. To see how to use it, simply run and it will bring up the usage message. At any time, if you run incomplete arguments or just run this upper command, it will give you the usage message. To initialize the locker, all we have to do is run some operation, and that will initialize the database, as you can see here, which will hold all the dedupe data that is added to this locker. Let's add some files and see how that works. Adding the first file, adding another file, and see how it deduplicates in the locker by checking the total size of the locker. Both of these files are close to 10 megabytes. So let's list the files. And let's look at the size of the locker. Now let's retrieve one of the files and verify its consistency with the original file that was added. The file is copied. Let's check its signature hash, and let's check of that of the original file. As you can see, both the hashes are exactly same.
Hi, I'll be showing how our GUI and web application work. Let's first start by opening the GUI client and creating a fresh locker. Our locker can handle adding different file types and folders. I will demonstrate by adding a text file, a folder, an image, and a PDF. Here I add an image, a PDF, a text file, and a folder. We can check to see that the files are available through our CLI client as well. We can now download these files directly to any folder, and here I'll demonstrate it. Let's first download the image file. The image file comes back successfully without any corruption. Next, let's download the PDF. The PDF also comes back without any problems. Last, let's download the folder. And the folder comes back with its contents. We can also delete any files with a simple two-click process. First, select the file you'd like to delete and click Remove. You can also delete the folders in the same way. This is our simple GUI implementation. Now let's look at our networked interface. You're greeted with a login screen, which I've already created a simple locker for the user Group10. You must first input the correct password or the system will not let you view the contents of that person's locker. I've already added a text file and a folder. Let's continue by adding the same image and PDF as before. Once all the files are added, the user is able to leave the locker and return it in another time. All contents of the locker will remain. Now let's download the image, the PDF, and check to see if the contents are the same. The image got downloaded correctly. Next, let's check for the PDF. The PDF also came back correctly. Finally, when downloading a folder, our system automatically zips the folder before sending it back to the user. Here I can open the zip file and see that the folder is there with its contents. This concludes our presentation. Thank you for watching.